Hi, EZmath&science is back for another tutorial because I received some questions about pH, conjugate acid, and conjugate base. So I'm going to be explaining from the beginning what is an acid, what is a base, and how to understand the concept of conjugate acid and bases. And again, I'm going to be talking about pH and solving the questions. So first of all, in order to understand the concept of um, what is a conjugate base or conjugate acid, we need to understand the definition of an acid and base, and we have several definitions, and the definition I'm going to use today is the Bronsted acid and bases definitions. So according to Bronsted, an acid is any substance that can donate a proton. So a Bronsted acid donates proton, and um, and reversibly, a Bronsted base accepts protons. It's any substance that can accept protons. So now that we understand what an acid is and what a base is, so I'm gonna be explaining the concept of conjugate base and conjugate acid. Um, since according to Bronsted, an acid is any substance that donate a protons, and if an acid donates a proton, there's something that remains, and the remaining thing is actually what the conjugate base is. And I'm gonna be giving you a sample example. So let's say I'm gonna hydrolyze HCl, for example, hydrochloric acid. So plus water. So what I'm gonna have, the thing is, HCl is gonna give a proton to water, so that I have H3O plus, because there's this hydrogen, it goes on the molecule of water, and therefore it protonizes water and gives us H3O plus, which is hydronium ion, and then plus Cl minus. And I told you that in a conjugate base, the concept of conjugate base is that when an acid donates a proton, whatever remains is actually the conjugate base. So in this case, Cl minus will be our conjugate base. And the same thing, since water accepts a proton from hydrochloric acid, is actually considered as a base. Therefore, this will be the conjugate acid, if you want to call it that way. So I'm going to do more examples so that you can understand the concept. And let's say I have ammonia. We use ammonia like as a typical example. So we have here NH3. Ammonia is considered to be a base, by the way, plus water. It's gonna give us NH4 plus OH minus. So in this case, in the last case, we saw that water behaved like a base, and in this case, water behaved like an acid, because ammonia gained one proton from water, and it becomes ammonium ions. So then OH minus, And if we're looking here, since this accepts a proton, it's considered a base. Since water gives a proton, it's considered an acid. And whatever remains from water is actually the conjugate base, and this is the conjugate acid. So that's the way it actually works. So I hope you guys enjoy it, and I'm going to be covering the next tutorials in another video.